welcome students. My name is Shampa. Today we are going to plot root 2 on the number line. Now we know root 2 cannot be expressed in the form of p by q. That is, root 2 is not a rational number. So what I am trying to say is this. We are going to plot an irrational number on the number line. In the past, we have plotted rational numbers, whole numbers, integers, natural numbers on the number line. But we have not yet expressed an irrational number on the number line. So now we are going to do it. Let's begin. Now all of us know the Pythagoras theorem. Let's quickly revise it. Say we have a triangle that is a right angle triangle. Say AB is the base of the triangle and BC is the height or the altitude of the triangle. Now what does the Pythagoras theorem say? It says base square, AB is the base square plus height or the altitude square. Here BC is the height. Base square plus height square is equal to hypotenuse square. So here AC is the hypotenuse. So we have AB square, which is the base, plus BC square, which is the altitude, is equal to hypotenuse square, which is AC square. So here, this is what the Pythagoras theorem says. Now we will use this theorem to plot an irrational number on the number line. Let's plot the number line. Let's use this part where we will use where the plot is for the inch side. So I'll tell you in a moment from now why I took this side. So let's draw a number line. So we know this is 1 inch, this is 2 inch. I'm taking a bigger scale so that we can actually understand the figure well. So let's take it as 0. Let's take this point as 0 and this point as 1 and this point as 2. Here we have 0, here is 1 unit and here is 2 unit. So this is 1 inch, this is 2 inch, and let's call this point as A. So we have OA is equal to 1 unit. Here in this case it is 1 inch. On this point, let's draw a perpendicular. Now I have marked the perpendicular. Let's cut a distance of 1 inch. So this is OB. This length is also 1 inch and this length is also 1 inch. I'm sorry, this is AB. I'll take this A here. This is OA and this is AB. AB is also 1 unit. So OA is 1 unit and AB is 1 unit. And we use the protractor to construct 90 degree and we cut out 1 inch from there. So this is a right angle. And let's join O and B, point O and B. Then it will become a right angle triangle. Therefore, triangle OAB is a right angle triangle. Now we know OE square, that is the base square plus AB square, that is the height square, is equal to OB square, that is the hypotenuse square. Now OA is nothing but 1 inch, AB is nothing but 1 inch, so 1 square plus 1 square is equal to OB square. Therefore, we have 2 is equal to OB square, or we can say root 2 is equal to OB. So, here we have got root 2. This distance is root 2. But this is not where we want to plot it. We want to plot it on this number line. So how are we going to do it? Let's see. Now we will use this. We will actually do a small trick. What? Let's see. With OB as the radius, let's consider OB as the radius. We know OB is equal to root 2. We just verified it. Now with OB as the radius, let's draw a semicircle. Let's cut an arc. Now, this point on the number line is root 2. This point is root 2. Now, the point is, why would you believe this is root 2? This is very simple. Very, very simple. We know OB is equal to root 2. We just verified it. Now, OB is the radius. And if we complete this circle, I made a semicircle so that it is evident that it's a circle, it's a part of a circle. But let's complete it for the sake of understanding it. If we complete this circle, we will understand that this point, let's call it D, OD. The point where the arc intersected with the number line, let's call it D. So, we can see that OD is the radius of the circle. And OB is also the radius. We know that in a circle, all the radiuses have the same length. And that explains why OB is equal to OD is equal to root 2. So that was easy.